And then I started fooling with it, and it's actually kind of fun.
Ay, ay. Hola, 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 hola. Hola, 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 hola. Listo, ya se escucha. Perfecto. Perfecto.
And I like it. It's not the best sounding instrument, but it's like it's like strange. To the end of Jedi level number 2, if you make it through all the Jedi exercise, I'm going to play the didgeridoo for you. And you can determine whether that's an incentive or a punishment. So hands-on exercise number 2, use the following operators and write expressions and assign their values to variables. Using the following operators, write expressions and assign their values to variables. So I'm just going to copy each of these and then go to the Golang playground, and I need to use them, and I need to assign their values to variables. And so there's the first one. And I'm just going to say, is 42 equal to 42? And if I wanted to, I could put parentheses around these. 42 greater than or equal to, do it like operation.
Eso está bien corto. ¡Ey, qué rollo! Jorge Carvajal, gracias por ese like, mi pana. Forgetters, gracias por ese follow.
Equals 42. 42 is not equal to 43. That's true. 42.
Está bien en corto. Pero pues vamos a hacerlo. Tururú, tururú. Sí se ve el chat, ¿no? Sí. Vamos a probar si funciona el chat. Ay. Se debería poner hola. Sale, funciona, perfecto.
2 is less than 43. That's true. And 42 is great.
Listo, todo bien. Cuéntanos de qué se trata. ¿Qué onda, Cristo? ALV. Saludos, saludos, ¿cómo estás? Pues ahorita estoy pues practicando.
Hands on
Estoy
exercise
aprendiendo.
number 3. We're going to create a typed.
Estoy haciendo ejercicios con el lenguaje de programación Golang. También para un curso que estoy haciendo. Ejercicio 3. Y ya. Pero sí, básicamente es programar así, una programación sencilla y así. Y el contador de acá al lado es para... A ver, aguántenme. El contador de acá al lado es por si quieren donar. Y si donan, se aumenta el tiempo. Y pues ya.
And untyped constants. Create typed and untyped constants. Print the values of the constants. So we'll come up here and we'll do const. And make sure you're doing these too. So if you haven't done it, pause this video and go.
¡Ew! ¿Qué pasó? ¿Eh? ¿Qué onda? Ven, pásate, salúdala.
¿A dónde está la cámara? Ah, la verga.
Pero ahí te
No mames,
ves,
qué pedo, güey. Yo viendo acá, güey, de repente acá, la verga.
Es que aparte ahí se ve otro fondo, güey.
Sí.
O sea, no está la pantalla, pero se pone un estudio mamalón.
Ah, güey, chochi, güey.
¿Cómo has estado? Oye, jálate el podcast.
Sí, güey.
Ya que ya has vivido experiencias que...
Ando bien riquita todo, güey. Pinche acá estudio verga, güey.
Gracias, bro. Cuando quieras estás invitadísimo, ¿eh?
Va, ya estás.
Cuando puedes para que se arme.
Pues, no sé, güey. Déjame.
Pues va a estar aquí un rato en la ciudad.
Sí, güey, pues está en prisa, ¿no?
En las semanas.
Sí, hermano.
Yo ahorita ando de vacaciones, por eso.
Va, bueno, te dejo, hermano.
Sale, pues. Nos
Gustazo,
estamos
güey,
viendo.
otra vez.
Un gusto saludarte. Ay, güey. Ajá. Constantes tipadas y constantes que no estén tipadas. Va. ¿En qué era? Ahí está, ya. ¿Y después qué? Ok.
To untyped constants. And so the first to let's take all this out, set it and 2 and E. And so we set 242, so we're not confused. I'm going to do my answer like that so we can see that, there. So that's my solution with how we do constants. For the
Ok. I've been fucked up, mirror.
emphasizing the fact that we could say the type here if we want or not, and when it's untyped, it's a constant of a kind, and then that gives the compiler a little bit more flexibility about how we use that value throughout a program. For hands-on exercise number 4, we are going to write a program that assigns an int to a variable, prints that int in decimal, binary, and hex, shifts the bits of that int over one position to the left, and assigns that to a variable, prints that variable in decimal, binary, and hex. So we want to assign
No, no.
an int to a variable, so let's get rid of 2, and then we're going to print, and then tab, and let's just run that. For 1. And so what you're going to have 1 0 1 0 1 0 0 because everything shifted ones to the left. Now, put a new line here. So you
Oh.
can see that more clearly. All right, so everything shifted to the left here, and that is number 84 or 54 in hex. So that's 5 times 16 is 84, right? So 5.
Okay.
5 times 16 is 80, plus 4 is 84. And then this is the ones place, twos place, 4, 8, 16. So 4 and 16 is 20, 32, 64. 64 plus 20, which is the 16 and the 4. 64 plus 20 is 84. So decimal, binary, and hex, all these bits shifted over one place to the left. So that's the solution for hands-on exercise number 4. And I'm going to put for hands-on exercise number 5, create a variable type string using a raw string.
Ahí está, ya está.
Literal and then print it. So this one is just to reinforce the fact that the raw string literal is something as a string literal.
Oh, okay, okay. ¿Cómo se pone ese símbolo? ¿Es este? Nope. Debe ser este, ¿no? Ya. No, ¿verdad? No, esta no es. ¿Dónde está ese pinche símbolo? ¿Cómo se hace ese pinche símbolo? Ya lo encontré.
You see? Another thing. Run. imported and not used, funct.println a. So what that meant was I'd imported this package and not used it, and that's the error the compiler hit. Here is something as a rostering literal, you see another thing. So that's the solution to hands-on exercise.
Okay.
For the next hands-on exercise, you're going to, using iota, create 4 constants for the last 4 years, print the constant values. So let's go to Golang Playground and go create this program, constant, parens, and using iota, so a is equal to 2 plus iota. Now you know what year I'm creating this training in. Always avoid telling people the year you build stuff, because then they're like, oh, it's dated. But hopefully it's still relevant if you're watching this in 2035. All right, 2017, print it, and now I'm going to print these variables out, except I should probably change them. B, C, D, and then print them out. Get rid of that part, and copy this. A, B, C, D. Except I want lowercase a, B, C, D. 2017, 2018, 2019, and 2020. All right, so we're getting to the end of Jedi level number 2, and the very last hands-on exercise is for you to take this quiz. So go take this quiz.
Okay. I tell you it's done.
Maslow's hierarchy of needs. You start out with the basic skills and knowledge, but then you also have the higher level stuff once the basics are fulfilled, the skills, knowledge, and then the motivation, the wisdom, motivation, and inspiration. Here's the didgeridoo, and it takes a couple of minutes to warm it up before it starts playing right.
Ya, descargar.
So now we're going to talk about control flow, and this first video here, we're going to take a look at what control flow is. We've already discussed this a little bit, but I just want to make sure it's covered. Like I said, my teaching philosophy is to give too much rather than not enough, and that way you either reinforce some of the things you're learning or things you already know, or you could just skip it if you already know it, or you know, if you need the material, it's there and you can go look at it. Or I give too much than not enough. So here's control flow, and you can read this on Wikipedia, and I'll just zoom this in a little bit so that you have it right here in the video and you can take a look at it. But control flow is the flow. It's basically how your computer reads the program. How does your computer read the program? When we read a book, we read it front to back. In most cultures, front to back, left to right, top to bottom. That's like the control flow of how we go through a book. For a computer program, it's going to go sequentially until it hits two other kind of structures. And one structure will be a loop. So you'll sometimes hear that called an iteration or an iterative. So now we're going to look at a loop, and before we jump into the loop, I just want to point out one resource. Back in the previous section, we looked at bitwise operations and bit shifting, and there's a good article right here that somebody pointed out to me. So if you click this link, it'll take you to the post on Twitter, where I posted a link to the article, and this article right here has a lot of good information about bitwise operations and bit shifting. So thank you, Vladimir, for posting this up. Appreciate the article. It was awesome. So I recommend that if you want to read a little bit more about bit shifting. All right, so the next thing we're going to do is we're going to learn about loops. And it seemed like there was something I wanted to say about that, but it must not have been very important. It'll come back to me if it was. So the Go playground, the first thing we're going to do, I remember what I want to point out to you. So as you're learning the Go programming language, a good place to consult is Go by example. And this is just like a good, quick lookup reference to like, oh yeah, how do I do something? You can even see Go by example loops right there, so you could click it. But they have a whole bunch of examples of how do you use different aspects of the Go programming language here. And so now I'm just looking for loops. And here's a for statement. And so here is for this, for I is less than or equals 3, or for j this 7, j less than 9, I plus plus. And so here are some examples of different loops that you could do. And so in Go, one of the interesting things about Go is that there's no while, right? There's no while in Go. And that's kind of interesting, and I'll show you how you program around it. But let's get started with the first loop. And so for the first loop, the way you create a loop is you're going to start with the for. So do this for this period while this is true. And the first thing that you put in is an init statement. So an init statement, we've learned about initializing a variable. First time you store a variable, the initial time you store a variable in memory, you're initializing that variable, storing a value in some cubby box in memory with an address. And so the first part is the init statement, and then you're going to have some condition, and then you're going to have some post. And so that's a good thing, just like right there, to kind of burn into your brain, that you have init, you have condition, and you have post. So I'm actually just going to copy that and drop this into our course outline. Cool. So now that we have that, we could actually fill this in. So the init is that we're going to initialize a variable, and traditionally I is the variable that you would use. So I'm just going to say, hey, I is equal to 0, and then here I'm going to put some condition in. So for I is less than or equal to 100, right? So this is going to happen while I is less than 100, and I'm intentionally not using the word while, but that's the word I want to use. While I is less than 100, this loop is going to run. So for I equals 0, while I is less than or equal to 100, and after every time you go through an iteration of the loop, it's going to run through this code, right? After every time you go through an iteration of a loop, I want you to add 1 to I. And this is the plus plus operator. So if we look at the Golang spec, which I already have open right here, and we go back up to the index and we look at operators, here, operators, we have the plus plus operator. So the plus plus operator, the minus minus operator, but that's going to increment our variable value by 1. So now we're going to start at 0. And it's going to run while I is less than or equal to 100. And so we could print out I and then run it. And now we printed out all the values from 0 to 100. So that's pretty cool. And the thing you want to take away from this is you start with for, and then you have your init, and then you have your condition, and then you have your post, and then you have your curly braces with code. So that's like the main thing you want to remember when thinking about loops. And we just use the for word in Go. Only the for word. So just the for, F-O-R, word, W-O-R-D. That's all we use in Go. Cool. So now we're going to see a loop within a loop. So we're going to have an outer loop, and it's going to run however many times we ask it to run. So there'll be the outer loop, and then we're going to put inside that outer loop another loop. And we could do that as many times as we want, but we're only going to do it 2 times. So this outer loop will say, okay, run, let's say 10 times. And it will run once, and then it'll say this inner loop, since that's what's in this outer loop's code block, this will loop, say maybe 5 times, 1, 2, 3, 4, 5. And then the outer loop will do its second one, which means this goes 1, 2, 3, 4, 5. And then the outer loop will do its third one, which means this goes 1, 2, 3, 4, 5. So for each loop on the outer loop, it's going to run the code inside. And the code inside is going to be another loop that runs each time the outer loop goes. So that's nesting a loop within a loop. So we'll just bring this one down to like 10. We'll stick with 10. And then I'm going to just copy that and paste it again. And we'll put one more curly brace in here. So now we have, if we format this, we have an outer loop. This is the outer loop. And then when that runs once, it's going to run the inner loop. And we're going to drop this down to just 3 times. And we will say less than instead of less than equal. So it'll go 0, 1, 2, 0, 1, 2, 0, 1, 2. So long as it's less than 3, it's going to run. This one is not going to run because it's you know, when it's equal to 3, it won't run. And we're going to change this to J. So we'll change that to J. I'll change that to J. So now we have a variable. The scope of I is right here. And then the scope of J is right here. So we have access to both I and J here. You can see scope of I right there. Scope of J right there. So right here you have access to both I and J. So we could say the outer loop, and we could use format printing, %b, or we could say %decimal, and then we could do a tab. The inner loop, and we could do %d, and then we could do a new line, and we have to pass in the outer loop is I, the inner loop is J, and I will print F that. And let's run it. Format the code, run. The outer loop, 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 10, 10, 10. And each time the outer loop runs, it runs the inner loop, 0, 1, 2, right? So each iteration of the outer loop does 3 inner loops. So that's pretty cool. If we wanted to, and I'll just break this up right here and put that into our code. Cool. So if we wanted to, we could take that and maybe break up the printing. And so I'm just going to copy this line and print that only on the outer loop. And I'm only going to print I on that one. And where would I want my new line? I want my new line after I'll take this one out. Let's see how this works. So that's going to be a tab, and then this one will be, we'll just do the outer loop and give it a new line, and then we'll have the inner loop, and the inner loop will be indented a little bit. There we go. And then so now I want to jump into the documentation and just make sure that you have familiarity with reading the documentation. So I thought we'd read it together, and then once we've read about for loops in the documentation, we'll take a look at how we do a for and just a condition. Because up to this point, what we've seen is the init, the condition, and the post. So let's go look at the documentation and see what the documentation says, and then after that, we'll explore the just doing a for and some condition. So if we go to the language specification, you'll see here we have 4 statements right up here in the index, 4 statements. And if I come down here, I have highlighted in green all the different things I want to read through and talk with you about. Maybe in this video, we'll only do documentation. That's a lot. So I'm just showing you this so that you have some experience and exposure to reading the language spec, because at first it could be a little bit unfamiliar to students. So a for statement specifies repeated execution of a block. Like, I just like the way they talk about programming. A block of code, a repeated execution of a block. There are 3 forms. The iteration may be controlled by a single condition, so that'd be for condition, a for clause, or a range clause. So here we have some EBNF. And if you've never heard EBNF wiki, and I don't know how you pronounce this, extended Bacchus noir form, EBNF, but it's basically the way that people write, syntax. The syntax that is used for talking about a language. And so a for statement, right? A for statement, 4 statements, that's what we're learning about, is equal to this for keyword. Is it a keyword? So we could go and just do Golang spec again and go straight to the index up at the top. And we can look at keywords. And so just making sure we're precise with the language that we use to talk about the language. And for is a keyword, so that's good. And again, this is a great way if you're ever coding with people and they're having differences, you could just always say, hey, what does the language specification say? What does effective Go say? And then go dig into language specification and effective Go. And then, a lot of times you can resolve differences in coding discussions by looking at the language specification, because who could disagree with Rob Pike, Ken Thompson, Robert Gressimer at a very high level, right? That's something you could do, but you have to be pretty Jedi to do that. The iteration may be controlled by for clause, range clause. So there's for, and then these brackets mean, hey, there's something optional here, and it could be a condition, or a for clause, or a range clause, and then a code block, right? So that's kind of EBNF. So for statements with a single condition. In its simplest form, a for statement specifies the repeated execution of a block as long as a Boolean condition evaluates to true. The condition is evaluated before each iteration. If the condition is absent, it is equivalent to the Boolean value true. For A is less than B, and then do something, right? So let's try that. So for statement specifies repeated execution as long as a Boolean condition evaluates to true. So let's go write some code. So I'm going to come in here to Golang playground. And we need some conditions. I'm going to do x : equals 1. And I'm going to do for, and I need some condition here. X is less than 10. And then my code block.
José Rojas Paredes, gracias por tu like, bro.
Block, and I will do format.println x and then increment x, and then I think that should be it. And then we can do a format parent line, done. And format our code, and let's bring it up so we can see the output. Run it. 1, 2, 3, 4, 5, 6, 7, 8, 9, done. And so here it's for some condition. Is x less than true? That has to evaluate to Boolean. Yes, that's less than 10. It's true. And then we print that out, and then we increment it. It becomes 2. Is that less than 10? Yes. Prints it out, increments it. So that's kind of like how you do a while statement, you know, in Go. So that's kind of cool. I'm going to copy this code and put it into our course outline. There we go. So now let's go continue reading about reading the language specification. So we read that one. 4 statements with a single condition. There's the single condition. 4 statements with a clause. And so here's what the clause is going to look like right here. A for statement with a for clause is also controlled by its condition, but additionally it may specify an init and a post statement. So here we have this EBNF for clause is equal to init statement, semicolon, condition, semicolon, post statement. And these are in between brackets, which means that they're optional. And so here's an example of the init, the condition, and the post. And we already saw this example, but it's cool to read how they wrote about it. So a post statement such as an assignment, an increment, or decrement statement. The init statement may be a short variable declaration, but the post statement must not. Variables declared by the init statement are reused in each iteration. So this is a short declaration, which means we are declaring there's a variable I, but we can't come over here and say I colon equals 2, right? I has to just assign, we could assign it, we could do I equals, but we can't do I colon equals because we don't want to redeclare a new I variable. We just want to assign to the current I variable. So make sure if you do assignment over there, in the post, it's only equal. If non-empty, the init statement is executed once before evaluating the condition for the first iteration. The post statement is executed after each execution of the block, and only if the block was executed. So that just tells you, hey, if this is non-empty, it's executed once before evaluating the condition for the first iteration. So this gets executed before this is evaluated, right? Init statement is executed once before evaluating the condition. The post statement is executed after each execution of the block, and then after you execute that goes. 4 statements with a range clause. So we're going to learn about the range clause in a future video. And then here we could see over here at the language specification or at effective Go how they talk about it at effective Go. But before we see effective Go, I just want to show you a little bit more code with the for. So this is where we left off with that one. We could also do it like this. We could take this out and we could do an if statement. So we haven't learned about if statements yet, but basically you just say if some condition is true or false. So I could say if this is true or false, right, then we want to do something. And one of the things we could do is we could break. Okay, so let's just look at that and take a look at that. So here we have x colon equals 1 for eternally loop until I tell you otherwise. And you can leave a loop with break. So if x is less than 10, well, that's not going to work, right? If x is greater than or is greater than 9, so when it's 10, we're going to break. Otherwise, we're going to print out the value of x and then increment x and then just come back here as x. So it's going to start out as 1 and come down here as 1 greater than 9. That's false, so this is not going to run. So it'll print 1 and then it'll take that 1 and make it a 2. And it'll come back up here as 2 greater than 9. That's false. So print 2, it'll make it 3. Is 3 greater than 9? Is 4, 5, 6, 7, 8, 9. 9 is not greater than 9. That's still false. So print 9. It'll become 10. Is 10 greater than 9? True. Break. Done. Done. Print's done. So let's format it and run. 1, 2, 3, 4, 5, 6, 7, 8, 9, done. So that's another way that you could do it. And you might have a reason for wanting to do it that way, but it's cool that you could use for with nothing there. And if you take my web dev class, we'll see how to do like some TCP programming where we'll just use for to create an eternal loop, which will be a listener, which is always listening for incoming messages. And so that will be running and always listening, and that's kind of neat. And maybe we'll play with this a little bit more and launch it into its own Go routine and create some concurrent code that can run in parallel where we have some loop just looping eternally, sending values back. When we get into Go routines, maybe we'll take a look at that. But that's using just for on its own. So now just returning, let me put this into our course outline. So now returning to reading documentation, let's just take a look at effective Go, and we'll kind of see the difference between the language specification and effective Go. But here in effective Go, they talk about the for statement, and in the for statement it says the Go for loop is similar to but not the same as C's. It unifies for and while, and there is no do while. There are 3 forms, only one of which has semicolons. There's for init condition post. So notice how effective Go is kind of like this is a little bit more how you use it. So there's for init condition post. There's for some condition, and we saw that like while this is true, run, while x is less than 10 or whatever we wrote, run this condition. And then there's just straight up for, and you can throw a break statement in there with some if statements whenever you want to get out of that loop. And we're going to learn about if statements here in a moment, a couple of videos down the line from this one. Short declarations make it easy to declare the index variable right in the loop. So for init condition post, init condition post, init condition post, init condition post. Like just get that into your head. So
¿Qué haces, bro? Hey, qué pedo. Josué, estoy estudiando. Estoy haciendo programación en Go.
You know, we're doing that deal, and so that's the for init condition post. And then here's the range. We're going to learn about range, and there's more range stuff there. And range is pretty cool actually with the string deal. So soon we will learn about the range one. But that's reading the documentation for the for statement, and it's pretty cool. It's pretty cool. I like it. It's fun. So we looked at the break keyword. We saw the break keyword in action. Now we're also going to see the continue keyword. And you can see here from the language specification that break and continue are keywords. So that's the word I want to use when I talk about them. Break and continue are keywords. So we saw how to use break in a loop. That'll break you out of the loop. Continue will allow you to continue doing the loop, but just from this point, wherever I hit continue, stop doing what's ever in this loop here, and then go to the next iteration. So continue just means like, okay, continue, right? And don't do anything else from this point down, continue to the next iteration. So let's see continue in action. So here's the code we left off in the last video. And I want to do something here with continue. And so the first thing I'm going to do is just go to the Golang playground. I want to show you how to get a remainder when you're doing programming. And so if I have x colon equal, and then I have like 41 and divided by 40, what does that give me? 41 divided by 40. Okay, let's format it and run it. And undefined x, because I have a capital X. Run it. And I have 1. I have 1. If I change this to, let me make this 43. If I change this to percent, that's going to give me the remainder. And let me get rid of that. So the percent gives you the remainder. See, the remainder of 43 divided by 40 is 3. So if I wanted to have, you know, the number of times it would go into it, and then also the remainder, maybe I'll make this 120, I'll make this 83, keep getting the same numbers. And then also copying this and make this y. Y will be my remainder, and this will be, you know, however many. So x, comma, y. Let's print that. So 40 will divide into 83 2 times, and the remainder is 3. So that's just, I want you to know about that remainder deal and how you get the remainder. So I'm going to put this this code into our course outline. There we go. And just so you know that is called, well, first of all, that is an operator. You can see that here in the language specifications, an operator. And in programming, that operator is called a modulus. Modulus operator, programming, wiki, or define, I don't know, wiki. We'll see what Wikipedia has to say about it. Modulo operation, modular arithmetic, modulus. Modulus is diminutive Latin word modulus, meaning measure or manner. The modulo operator, percent, or mod of various programming languages, so that kind of speaks to it right there. I don't know what this one says, I haven't read it. But anyhow, that's called modulus. All right, so let's go back here and let's take a look at our code. And now we want to use the modulus operator, and we want to use continue, and let's say that we only want to print even numbers. So right now we're printing all numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. But let's say we want to print even numbers all the way from 0 up to 100, only even numbers instead of like all of the numbers. And so to do that, we got to think about the logic here. And one of the things that we want to do is we want to check, right? So first we'll have our break statement up top, and that'll be the first thing. So if we hit something greater than 100, we're done. And then the next thing we want to do is we want to have if x modulus 2 is not equal to 0. And so let's see if this makes sense, right? So this comes through 0. Is 0 greater than 100? No, that's false. So this doesn't run. And then we come down here, and 0 divided by 2 has no remainder. And so that is equal to 0. And let's just confirm that. 0 divided by 2, Golang playground. So we're just thinking through the logic on this. 0 divided by 2. 0 divided by 2. Let's see what happens. 0. Okay, cool. So that's fine. And we can also do 0 modulus 2. Let's see what happens. 0. All right, so we're all good there. And then it comes down to the next one, and it's going to print x, and then we increment x. What happens when it's 1? So 1 modulus 2 is 1. Okay, and 1 divided, we'll put both these here. And 1 divided by 2 is going to be 0, right? So the next one there, if it is 1, if this is 1 not equal to 0? 1 is not equal to 0. So when we have 1, 2, it's going to print out 1, and then, oh, it's going to continue. So it's 1, 2, we'll say continue. There we go. So continue, so it'll come back up here, but we didn't increment, right? We didn't increment. So it hit here, it came back up here, it's still 1, it's still 1, it's still 1, right? It never gets to this because it goes from x equals 0, goes all the way through, prints it, increments, comes up here, becomes 1, and then, becomes 1 right there, and then it goes to here, and 1 divided by 2, or 1 modulus 2 is 1, so that's not equal to 0, so we hit continue, and it never gets to the increment. So we need to put the increment right at the top. And now we're going to see this run from 1, because we'll immediately come in and it'll be 1. But if we wanted to, we could just start at 1, and then it starts at 2. And so if it's 2 modulus 2 is not equal to 0. So we're going to skip that, right? Because 0 is not equal to 0. That's false. 0 is equal to 0. So this we skipped, and it'll print 2, and it'll come back up here and become 3. 3 is greater than 100. 3 modulus 2. 1 is not equal to 0. True. Continue. True. So it'll continue, right? Because we don't want to print 3. And it'll come up here, and so on. Let's run it. So 2, 4, 6, 8, 10, 12. So print it out all the even numbers. That was a little bit of a walkthrough to kind of figure out what's the logic and what flow do we need to make all that code work. But I hope that made sense to you. And the main thing that's being illustrated here is that break is running and continues running. So I think it can be valuable to see how a teacher works through code and thinks about code and looks at the logic and how's the order going. Sometimes you have to step through each iteration to make sure, oh, is this logic happening the way I want it to happen? And then think about what you want to happen and rearrange things so that they happen correctly. That's always really helpful to my students in the classroom, which is why I include it here. So even though there's sometimes a little bit of fumbling and it's not like perfectly produced in 34 seconds, you see me do it like I'm a rock star. But instead, I like to give the human experience because that's how we learn as humans. We actually see somebody else do something and see them wrestle with it and massage it, and then they get it right. And that's how we all code. And so too often that isn't modeled in online classes. So I like to model that and include that in my classes. To that extent, I am now going to give you a little hands-on exercise. I was going to call it a challenge, but I like the word hands-on exercise better. I think it has better connotations. So here's a mini hands-on exercise. We learned in a previous video how to print the different characters of a string, and we saw format printing where we could do that. So go to the documentation, look at the documentation for format printing. Remember, one was like %, uppercase U, to print the Unicode character. And I want you to loop over the numbers 0 to 200 and print them out as text. Because if you remember, if we look at ASCII, and let's just set this up here. If we look at ASCII, so scroll down, here's ASCII, and we have binary, occ, decimal, and hex. And if we look at the decimal, 0 is going to print out, null. 1, so just print out, let's see, we just start the letters. Just print out, starting with decimal 33. So if we loop from 33 all the way up to 90, loop from 33 up to 122, 33 to 122, and then print out each of those numbers, but then also show them as a string. So start out by printing the numbers, and then see if you can get those to turn into the letters. So that's the mini hands-on challenge, using format printing. All right. Now I'm going to try to figure this out with you. And so I'm going to go to godoc.org, and I'm going to go to /funct, and that's going to take me to the funct package, and there it is right there. So I'm going to hit that. And I'm going to come through here, and here are my formatting verbs, the verbs, right? %v is the value in default format, %d is base 10, and when we use %v and we have a number, so there's
recording in progress.
I'm going to use my super simple highlighter. Don't know if you know this, but Google Chrome extensions. Okay, you can go find extensions and add those onto your browser at Google Chrome, and then you can do cool stuff. And that's a super simple highlighter, so you can highlight web pages. I grew up old school where I love highlighting stuff. So here is, we have %v, it prints out an int as %d. And then a string, we have %s is the uninterpreted bytes, double quoted string. %x is lowercase 2 characters per byte. And if we scroll down, we have write x if the character is printable for %u. This is Unicode, right? So it prints out the Unicode stuff. So %pound capital U. So we'll check that out. So let's see what we can get working here. So to do this, I'm going to create a loop, and that loop is going to be for, and then we'll have our init, : equals, and we go from 33, and then we're going to go I is less than or equals to 122, and then we're going to do I++, and then we'll print something, and we'll come here. We're going to use format printing, and so with the format printing, we will use and we can go over to godoc, and we can look through to see which different ones we have. We'll just do %v right off the bat and see what we're getting, %v, and we'll do a new line character, format it, and we need to add in what we want to print and run it. And now we have 33 through 122, and that's going to correspond with our ASCII. 33 will be the exclamation point, and through 122 will be through lowercase z. And you can see that right there. Decimal 122 is lowercase z. So we're printing all that out. And if you remember from when we were looking at strings, we saw this one here, %pound u, just to show you that again. There's the %pound u. And we can come in here and we can do a tab and %pound u, and a new line there, and then just add that, just one of them, and format it and run it. And so now we have printed out all of the ASCII characters and their code points. That is pretty cool. One thing I might be interested in doing, just like looking at this, would be the hexadecimal. And so for hexadecimal, I'm going to have that tab and then pound X and then another tab, and let's run that. And we're gonna need one more character. There we go. And notice the error on that. I did that kind of quick because there's still, even in me, a little embarrassment if I have an error. Like, oh, quick, cover it up, fix it, show it. But, you know, the U is missing. And here's the U, right? We're missing that. It's like, hey, I hit %, and there's not a U. Duh, it's missing. So if I add that in, right, a value to pass to U, then it runs. So there's hexadecimal. Notice how those correspond to the Unicode code points, right? That's in binary, that's in hexadecimal, and then here's that character. There's that rune, that code point. All right, kind of cool. Don't feel bad at all if you didn't get this challenge. That's why I didn't assign it as a whole hands-on Jedi exercise, which I expect you to solve on your own. This challenge was a little bit more challenging. There's a couple of nuances to it, so don't feel bad if you didn't get it. You're doing awesome. You're doing great. So now we're gonna look at if statements, and I put into the course outline here that
Dun, dun. I need you to stand. Tres minutacos y me voy.
Buenas tardes, chicos.
Ya empezó mi clase, chavales. Los tengo que dejar. Muchas gracias a todos por ver. Bye.